Welcome to PM Ready, your guide to becoming PMP certified. This is the lesson on the project lifecycle. For this lesson, I have consolidated information from the PMBOK guide, the standard for project management, and the appendix X3, and brought information from all of those different locations into this one lesson so that we can talk about the project lifecycle, the product lifecycle, and how they're different, what project phases are, the development lifecycle, as well as the PMI process groups and the PMI knowledge areas. The project lifecycle is the series of phases that a project goes through from the start to the end of the project. Different projects can have very different life cycles and different phases that they go through, depending on the type of project, the type of organization, the industry, the different development approaches that you could choose, whether predictive or agile or some other approach, the technologies that are used, even the tools and materials. However, despite their unique differences, each project will follow these same basic generic phases. Starting the project, followed by organizing and preparing and planning the project, followed by carrying out the work of the project, and finally the ending or closing of the project. It may not look like it at first, but even agile life cycles fit into this generic model, because even with an agile project, you'll still start with a high-level initiation process, some high-level planning and preparation, and you'll still have a high-level closure at the end of all of the work that happens in the middle. And it's that phase in the middle, or those phases in the middle, which will each have their starting, preparing and planning, and carrying out and ending the work. So each sprint, for example, will have these generic phases in the sprint itself. In addition to the generic phases of a project lifecycle, each project will have its own different phases depending on the project and its unique needs. Some examples include things like concept development, especially in creative projects in which you may need to explore with key stakeholders the general concept and idea of what you're trying to accomplish. It may also include a feasibility study that may be necessary in order to determine whether or not the project is even possible or economically viable. You may have a phase specifically dedicated to gathering customer requirements. Another phase called solution development, which would be the exploration of different possible solutions to business problems, as well as to explore how to meet different customer requirements. You may also have a design phase. Visual design is a common phase when designing a website or an application or some other kind of system. The visual design is the process of creating the look and feel of the various screens, exactly how they would look when finished, and refining those with key stakeholders and getting their approval before moving forward. Another phase that might be valuable is a prototype phase, in which you can explore not only the feasibility of a proposed solution, but also get feedback from key stakeholders. Finally, of course, you would have a build phase in which you do the work of creating the key deliverables. You may also have a separate test phase, which tests and validates. A transition phase, in which you take the work that's been done and transition it over into operations, and handing over the work that you've done and providing them with everything that's needed for them to properly run or support what you've done. In larger projects, commissioning is a specific phase, which, similar to transition, involves checking and testing everything that's been done and getting it up and running. Because different projects can be so different and have such unique needs, PMI does not, of course, and cannot dictate what the different phases should be for your project. But they do specify one thing, and that is that each phase should end in the completion of one or more deliverables. So at the end of your concept development, you should have a deliverable that expresses the concept and the decisions that have been made about that concept. A feasibility study phase should result in a feasibility study. Customer requirements should end in a requirements document. A build phase should end in some deliverables that can be tested and transitioned over, and so on. It's also important to note that each phase, regardless of what it is, should include a cycle of all 5 of the PMI process groups. Each phase, no matter what it is, should have a little bit of initiating, some planning, some executing of the work of that phase. It should include monitoring and controlling of that work, as well as some sort of closure of that phase. Even agile projects that have short, repeated iterations of work, for each of those iterations, there is some initiating process, some planning that goes into the planning for that iteration, the work of that iteration, monitoring and controlling of that work, and the final closure of that phase or iteration. How much it costs to make a change to your project depends a lot on when you propose that change. Early on in the project, it's pretty easy to make changes, even big changes, when you're in the early design and planning stages. But later on, after a lot of work has been done, it can cost quite a lot of time and money to go back and redo work that's been done in order to accommodate those changes. This graph represents this change in what it costs to make a change during the life cycle of a project, starting out low at the beginning and increasing, sometimes exponentially over time, until it becomes prohibitively expensive by the end of the project. Risks, on the other hand, tend to start out high at the beginning of a project and then decline slowly over the course of the project. There are a couple of reasons for this. One is that at the beginning of the project, there are still a lot of unknowns and a lot of risks that haven't even been identified, and there's been no work done to mitigate any of those risks. But as you go through the planning processes, you identify those risks, come up with a proactive plan to manage those risks, and so those risks tend to go down as a result. The second reason is that as you progress through the work of the project, tasks that were risky are completed, and so those risks are no longer relevant. A phase gate is simply that point at the end of a phase at which you review the phase and the work that's been done, the performance and how well things have gone, and you make a decision about what to do next. You could decide at that point that the phase has gone well and that you're ready to continue on to the next phase. Or you might decide that there are some changes that need to be made and it's okay to proceed, but that you need to make some modifications as you move forward. Or you might decide that things have gone very poorly or circumstances have changed, and now is a good time to simply end the project. Or you may decide that the phase needs some rework and that you need a little bit more time, and so you decide to remain in that phase and continue work until later, and when that is done, you'll come back to this phase gate again and make a decision. Or you may decide that a lot has gone wrong with the phase or something's changed and you need to start over and repeat this phase again. A phase gate can have various names depending on your organization or industry. It could be called a review or a stage gate rather than a phase gate, or a kill point or a phase entrance or exit. But whatever it's called, it has this same purpose, and that is to review the work of the previous phase and to make a decision whether to proceed or not. A go, no-go decision. In your phase gates, some of the documents that you should use to determine whether a project is going well or not include the project business case, the project charter, the project management plan, and the benefits management plan. The project management plan should specify when these phase gates should be held, who should be present, and the structure of the meetings and what should be reviewed. It will also contain a lot of detailed information about how to measure progress against scope, schedule, and cost and quality and so on. The project business case will help you to see whether or not the project is still on track to deliver the business value that was planned. The benefits management plan will help you to determine whether the project is still on track to deliver the long-term benefits that are expected from doing this project. And the project charter will help you to see whether or not the project is on track within the original high-level specifications of requirements and tolerances. Whatever the phases are of your particular project, those phases that are involved in doing the work of creating the product or service can follow different development life cycles. PMI has identified and categorized these into a few different categories. We'll start first with what they call the predictive development life cycle. This has traditionally been called the waterfall model or the plan-driven model. This is the type of development life cycle in which all of the planning is done up front, and at the beginning of the project, you determine and fix what the scope of the project is going to be, how long it's going to take, and what it's going to cost. And once those three factors or constraints are fixed, change is then very tightly controlled and managed in the project. Change is generally discouraged because it interferes with this plan, and change is only approved if absolutely necessary. And in this type of development life cycle, generally the final result is not really usable until you're completely done with the project. This is called the waterfall development life cycle because generally these phases are very separate. You've got a planning phase, a design phase, a build phase, a test phase, and then a transition or handover phase. In this approach, you do the work of each phase until that phase is done, and you don't start the next phase until you've completed the previous one, and you don't generally go back and revisit previous phases. When you've done the planning, you're done with planning, and then you move on to design. When you're done with design, you wrap that up and you start building, and you don't go back and redesign. So because these have such hard breaks, they're often depicted as these phases that flow one into the other like a waterfall. This waterfall approach is what has traditionally been used and is still often used for projects that are pretty predictable and don't have a lot of uncertainty involved. Things like designing and building a house or a building or a bridge or a freeway. These are very well established disciplines and industries in which they have a lot of experience, and it's reasonably predictable what it's going to take to accomplish these ends. The other main category of development life cycles that PMI has identified is the category of adaptive or change-driven development life cycles. And they've identified several different types of adaptive life cycle, but in all cases, these life cycles are for projects in which change is more likely to happen, either because the requirements or other aspects of the project are uncertain, or because there are certain risks involved that may necessitate change on the project. The first of these subcategories is the iterative development lifecycle. This type is very much like the predictive or waterfall approach, but it has some predefined points along the way at which you review the progress and get feedback, and you actually expect and welcome and incorporate changes on the project. The incremental type is iterative, but in the iterative life cycle, the scope is fixed, but the time and cost estimates are routinely reviewed and modified as needed. The incremental life cycle is iterative in the sense that it generally has fixed time frames, and at the end of each of those fixed time frames or iterations, there is a usable result at the end of each of those. It will be incomplete, of course, but the idea is that there's something of value that can actually be used at the end of each iteration. And finally, agile approaches are categorized as both iterative and incremental. The appendix includes this development life cycles spectrum or table, which shows the spectrum of development life cycles from predictive on one end of the spectrum to agile on the other end, with iterative and incremental in between. This should help you to visualize that iterative is closer to predictive and incremental is closer to agile. The more frequently requirements can be reviewed and elaborated during the process, the more agile it is. The more often delivery is divided up into subsets of value determines how agile it is. The more often change is incorporated as a regular part of the process, the more incremental or agile it is. The more key stakeholders are involved regularly or continuously, the more it tends toward the agile side of the spectrum. Predictive life cycles are all about planning everything up front and determining things ahead of time. Iterative allows for a certain amount of flexibility in cost and schedule, but not around scope. Incremental has more fixed timeframes, and agile incorporates all of these more agile processes involving stakeholders continuously, incorporating change on a regular basis, and having very frequent delivery of product. Of course, you can also use a hybrid approach in which you combine some elements that you manage in a predictive way and others that you manage in a more adaptive or agile way. For example, suppose you're developing a new IT system that involved both hardware and software. The hardware requirements and the network cables and everything that need to be in place may be pretty predictive and easy to define up front, and so you could manage that in a predictive way. On the other hand, the software itself might be something that you need to manage in a more agile way. No matter which development cycle you choose to use, or a combination of different development cycles you choose to use, all of your projects will still follow this same basic pattern of 5 process groups, starting with initiating, planning, executing, monitoring and controlling, and closing. The initiating process group is about developing the project charter and the stakeholder register, basically figuring out who's who on the project and figuring out at a high level what it is you're going to do in the project. This applies even to iterations because you still have your sprint or iteration planning in which you define what it is you're going to build during that particular iteration or sprint. Then comes the planning process group, where you develop the project management plan and other project documents, or in the case of a more agile approach, you do some of the detailed planning on the particular items that you've chosen out of the backlog to work on in this sprint or iteration. The executing process group is about creating the project's deliverables and a lot of communication, of course. This is what you would do in a phase of the project, including a project sprint. Monitoring and controlling applies as well, regardless of your life cycle, because no matter how you're doing this, you need to have some measurements. You need to have the ability to forecast your performance and what you think you'll be able to finish in this phase or iteration. And you also need to manage change requests and get those approved as needed. Finally, you have the closing process group, which delivers the final product or service or result transition and provides a final report for the project. This diagram shows how these 5 process groups can overlap, with planning and even monitoring and controlling starting before initiating has finished, and with the closing process group starting out somewhere during the project and then finishing at the end. Most projects will have at least some degree of overlap between these process groups. For the different phases of a project, this diagram can represent the overlap in processes within each phase. PMI has organized the various project management processes into 10 knowledge areas, covering scope, schedule, cost, quality, resources, communications, risk, procurement, stakeholder engagement, and integration. Each of the project management processes is organized into a PMI process table with the 5 process groups along the top and the 10 knowledge areas along the side, and with every process in its appropriate location. We'll be covering this process table in some depth in later lessons. It's important to distinguish between the project lifecycle and the product lifecycle. The project lifecycle is the cycle that we go through of initiating, planning, executing, monitoring and controlling, and closing a project, the time from the beginning to the end of the project itself. The product lifecycle is the whole lifecycle of the product during and after the project, which may extend for many years after the project is finished. It includes the concept, the delivery, the growth of the product, its maturity, and even eventually the retirement of the product. Things to remember from this lesson include the project lifecycle and the PMI 5 process groups of initiating, planning, executing, monitoring and controlling, and closing. The product lifecycle and how it's different from the project lifecycle because it extends throughout the entire lifespan of the product itself. The project phases, each of which ends in the completion of a deliverable. The development lifecycle, which can be predictive, iterative, incremental, or agile. And the 10 PMI knowledge areas: scope, schedule, cost, quality, resources, communications, risk, procurement, stakeholder engagement, and integration. For more information, you can see these pages of the PMBOK guide. PM Ready is a publication of PM Guaranteed and is based on the Project Management Institute's PMBOK guide.